Oh, hello. Sorry, didn't see you there. I am MD Davis, or MD for short, and I am going to teach you all about the wonderful world of calculus. Now, I was emailed the other day and asked, MD, how do you graph cubic polynomials? And I'm glad he asked, or she, because I will show you how to do this. Now, I'm going to check in with you every few times. I'll write it down on a piece of paper, make sure everyone's got it. I won't do it every single step, but I'll do it once in a while. So let's begin. First, we need an equation. Let's start something basic, nothing too hard. F of x is equal to x to the third minus 2x squared minus 3. Why not 3? Okay. Now, we're going to take the derivative of this equation. Now, for those of you who don't know how to take the derivative, very simple thing. You take the exponent, put it in front, you multiply by whatever is in front of the x, and then subtract 1 from the exponent. So for x to the third, you take the 3, put it in front of the x, it's just 1x, so it's 3 times 1, 3x, subtract 1 from the exponent, which originally was 3x squared. It's not that hard. So x to the third, is when derived, is 3x squared. Minus 2x squared, you take the 2, multiply that by the 2 in front, that's 4x, subtract 1 from the 2, that's 1, so minus 4x to the first, just minus 4x. And minus 3, 3 is raised to nothing, 0, 0 times 3, 0, so that's out. So we have 3x squared minus 4x. Now we're going to set this equal to 0, because we want to find the critical point. This is going to help us a lot later on in the graph. And we can be done after this step, but we're going to make sure with the second derivative. But we're going to worry about that later. Moving on. 3x squared minus 4x is equal to 0. So now we notice that there's an x in both of them, so we can factor 1x out. So x times 3x minus 4 equals to 0. And if you notice, this equation can be found with x equals 0 and x equals 4 over 3. If you have it so far, this should be what you have. That's the original equation. This is the derivative of that equation. This is after we factor out the x. And again, these are both set equal to 0. And to make it 0, x has to equal 0, because 0 times, if you put 0 in for x, the entire equation 0, or 4/3. I don't know if you can see that, but here, let me make that a bit more clear. There you go. I don't know if that did anything, but whatever. 4/3. So you have 0 and 4/3. We know those are both our critical points. Now we're going to see whether these points, before, between the 2 points, and after the 2 points, whether the graph is going to be going up or down. Alright, up or down. Alright. Anyway, so we're going to take 1 point before 0. The easiest point would be -1. A point after 0, the easiest point will be 1, and between 4/3. The point after 4/3, which would be 2. So if you plug -1 into the derived equation, you will understand that the graph is going up at that point. -1 times 3 times -1 minus 4 is going to be a positive. So it's going up. If it's a positive, by the way, it's going up. If it's a negative, it's going down. If you plug 1 in, you can do all this math later, it's going down. And if you plug a 2 in, it's going up. These are just random points that I plugged in. Again, they're 1 below 0, 1 between 0 and 4/3, and 1 above 4/3. Just random points. You can pick whichever one you want. Next, we're going to take the second derivative. This is to check the concavity of the graph, just to make sure. It's not a necessary step, but it helps with the process. So we're just going to do the same thing we did with the derivative for the original equation, except we're going to derive the derivative. So 3x squared, you bring the 2 down, 6x, and minus 4x raised to the first, just minus 4. You should have that, 6x minus 4, and that's double sign. And now we're going to solve for 0 again, so we're going to set that equal to 0. And if you notice, x can only equal 2/3. I guess I decided to check every time, just to make sure there's no confusion. Okay, x equals 2/3. So, with that information in mind, we take, again, random points below and above 2/3. The easiest ones would be 0 and 1. So 0, 1, we plug that into the second derivative equation, and you'll see that if it's equal to 0, it's going down, and if it's equal to 1, x is equal to 1, that is, it's going up. So between 2/3, 0, concave down. I did this wrong. I apologize. It's just concave down, which means it would look something like this, and concave up is that. So, concave down, concave up. That's kind of what our graph is going to look like, something with those connected, so something like that. Anyway, now we can draw the graph. I'm going to draw it on the side here. All right, now we have critical points, so we know the highest point on the graph is going to be at 0, because that's where it's concave up, and the lowest point is going to be at 4/3. So, if we draw this graph correctly, it should look something resembling this right here. It's highest at 0, lowest at 4/3. You probably can't see that, it's too low, but this will be our 4/3, 4/3, and then it goes up again until infinity. Basically, this entire thing just takes first derivative, these will give you critical points, second derivative, is going to find concavity, and taking the random points can tell you anywhere from negative infinity to the first number is going to be either up or down. Anywhere between the next two is going to be up or down, the two numbers that you got through critical points. And any number, the random number that you picked after it, if it's up or down, it's going to be going up forever or down forever. That's all you need to know. This has been another great lesson with MD Davis, MD for short. And I'll see you all next time.